Hi everyone. Today we are going to move on and do another clustering algorithm, and that is called Dbscan. The full name of the Dbscan is, as you see, density-based spatial clustering of applications with noise. Okay, it is really long name. Well, and a lot of time people really don't know the full name of the Dbscan, but Dbscan is a really popular name. Another thing about Dbscan is probably one of the youngest machine learning algorithm we have covered in this course, and the majority of the machine learning algorithms could be 20 or 30 plus year old, and the DBscan is only like less than 20 years old, I believe. Okay, so the process of the DBscan is also kind of different. Instead of focusing on clustering the samples and then assign the cluster labels, the first thing or the first several rounds, what we are doing in DBscan is we are trying to classify each of the sample into three categories. So the number one, well, if we say this sample or this point is a core, and this means, well, within there should be at least a specific number of the samples within a radius specified as a epsilon. Okay, so well, for example, if we say the mean point is a 3 and then the epsilon is 10, so this means if we draw a circle around this sample and with the radius as 10, and then we are expecting there are at least 3 samples in this circle, so we can call this a core. Okay, so the next part, well, if we have a point and, well, it has fewer than the mean points within the epsilon radius, and however this sample lies within the epsilon radius of a core point, and then we have a border point. So for border point, and again we are drawing a circle of the epsilon, so for example as the radius as 10. Okay, and then if we count less than 3 points, so if we are using the mean point as 3, however if we see less 3 points, so this point can't be a core because there are less than the mean that there are less than 3 points in this circle. However, within this circle, I do have a core point, and this will make the current point a border point. Okay, so those are the difference between the core and the border. And other than that, if a point is not a core, it's not a border, and then this point will be a noise or a outlier. Okay, so those are the three different categories of the points. So our goal in the DBscan is, first we want to check each of the sample and then try to classify those samples. Okay, so for example, if you're using this data set, okay, so if we use the mean points as 3, and then we are drawing a circle on all the points, and then we count, are there 3 or higher number of the points, and if there are, and then we will say this is a core. Okay, so we only find 3 cores in this case, and then inside of each circle, for the non-core points inside the radius of the circle of epsilon, and then they are the border points. So for all the black dots, and they are border points. And after that, so for all the other points which are not which are not cores, which are not borders, and they are noise. Okay, so all the white samples will be the noise. Okay, so well, after we have classified each of the sample, and then we just connect all the core points if they are within the epsilon radius of each other. And after that, we further associate the border points to the same cluster as the corresponding core points. And then we will have the clusters. Okay, so well, in this case, I hope that I can connect those two cores together to make those two cores the same cluster. But I can't do that because the distance between those two chords, they are higher than epsilon. So if we say hypothetically there is another chord here, so if hypothetically there's another chord here, and then I can connect those three of the chords together, and then I will form one cluster. And then for all the nearby border points, and they will be assigned to the corresponding chord points. So those samples in this area, and they will all belong to one cluster, and then another cluster will be here. Okay, so this is how we assign the cluster labels. And you may ask, okay, we just assign the cluster labels for the core points and also the border points, and how about the noise points? And the answer is, for the noise points, we don't bother to assign them a cluster label, or we assign them a special cluster label saying they are the noise item. Okay, so let's just do a very small example with the two moon-shaped dataset, and we have been dealing with this kind of dataset a lot. And for this one, it's a slightly different one because we are if you see the spread of the samples, and then they are much tighter than the moon-shaped dataset we have done before. Okay, so the idea is we have two clusters, and for the two clusters, they are both in the moon shape. Okay, so how do we cluster those samples correctly into two moon-shaped clusters? And let's try the k-means. So for the k-means, we know there are only two clusters, right? So we specify the n cluster to be 2, and then this is the result. So take a look. That's not good, right? That's not good. So what's the reason? Well, remember, for the k-means, we are expecting the shape of the clusters to be round or something similar or something close to a round shaped cluster. Why? Because the centroid will be the mean of all the samples in the same cluster, right? So we are expecting the centroid to be in the middle. And then when we are assigning the nearby samples to the centroid in the next round, and then we are also the centroid will also grab the nearby samples in a round shape. So even though we didn't say that explicitly in the k-means, we are expecting all the clusters to be kind of in a round or a spherical shape. Okay, but in this case, we have two clusters in the moon shape. So this is not true. So we are going to have a big problem. Well, and if you want to consider Dbscan, and for the Dbscan, what we will do is we will just assign the we will just classify each of the sample into three categories: the chords, the border, or the noise, right? And then we are going to connect the chords together. So when we are connecting the chords together, we can connect one chord to another one, to another one, to another one. So we can do the moon-shaped clusters with the Dbscan. The reason is when we are connecting the nearby chords, we don't really worry about the direction. This can be a moon shape if a moon shape of the core points are connected, right? So this is this data set is much more promising to be solved with Dbscan. Okay, let's try that. So we create a Dbscan, and then we specify the epsilon, and by eyeballing, I'm gonna do a very small epsilon as a radius, and then for the mean sample, I think 5 will be a reasonable guess, and then I specify the distance matrix to be Euclidean. Okay, so in this case, when you see the distance matrix, and you may want to do a standard scalar, and in this case, I noticed that the range of the x and y are not exactly the same, but they are not far away from each other either. So I didn't do the standard scalar in this case. But usually, remember, when you see there is a distance matrix, you may want to do the standard scalar. Okay, and then if we just do this, and after and then we can get we can do get the cluster labels of the Dbscan, and then using this using the labels as a C, and we can visualize the the clustering results of the Dbscan. And as you can see, well, we have a much better clustering results. Well, after we have done the Dbscan and we can get the labels. So in this case, we have only zeros and ones. Well, they are showing two different cluster labels. And if you want to check the unique cluster labels, and you can see again, we only have 0 and 1. And I want to try something different. I want to reduce the epsilon. So by reducing the epsilon, and then we are more likely to have noise. We are more likely to have borders as well, right? So, well, I'm just trying a smaller epsilon, and well, I'm happy to see there is a third color. So, well, I have the blue and the pink, and then I have another lighter blue. And if I want to check all the labels, and then I see -1. So this -1 means, well, this sample has been classified as the noise, and then Dbscan will give us a -1. Okay, so the next part is, well, I know there will be some of the noise, and by the way, surprisingly, this one is a noise, but this one is not. Okay, so if you want to play with that, you can try even smaller epsilons, and then you may pick up more of the noise data. Okay, so the next part, what I want to do is I want to create a mask. Well, true means that is not a noise, and false means that is indeed a noise. So I want to apply this mask to this dataset again. So I want to do one more step to filter out all the noise data detected by the Dbscan. So I'm still showing the same visualization. However, in this case, since I have already removed the only one noise sample, and then I have a cleaner visualization of the two clusters. Okay, so well, this video is already long enough, and I'm gonna continue in the next video.